This is the temperature versus solubility worksheet 2. We're going to go through and do this real quick. The first thing it tells you to do is says use the information in the table. So this table right here to graph the solubility curves for these 4 substances. So they give us 4 different temperatures for each one. So I'm going to have, I'll use a dot for barium hydroxide. I'll use an X for copper sulfate. I'll use a square for potassium chloride, and for sodium nitrate, I'll use a circle so we can tell those apart. So let's just plot barium hydroxide, 1.67 at 0. So that's going to be down here, almost on this line. Then at 20, it's 3.89. So it hasn't risen very much. At 60, it's 20.94. And at 100, it's 101.4. So put it about right there. Then we're going to draw a smooth curve through all these data points. Just like that. So that's the barium hydroxide line. For copper sulfate at 0, it's 23.1. So I'll put an X there. At 20, it's 32. At 60, it's 34. Oops, I messed that one up. At 60, it's 61.8, so it's going to be all the way up here. Get some white out. Get that out of the way. And at 100, it's 114, so it's going to be above this one. In KCl, at 0 is 28. So I'll put a square there. At 20, it's 34. So a square there. At 60, it's 45. So a square there. And at 100, it's 56. So a square there. So let's draw our line. And then sodium nitrate at 0 is 73. So put a circle. At 20, it's 87. So put a circle. At 60, it's 122. And at 100, it's 180. So all the way up here. So that's what your 4 lines should look like. So then let's answer the questions down at the bottom. Number 1, at about what temperature will 100 grams of water dissolve equal amounts of potassium chloride and barium hydroxide? Well, that's where the lines cross. And I would say that they cross at almost 90. We'll say it's 85 degrees. And then number 2, at about what temperature will 37 grams of copper sulfate and potassium chloride dissolve? That's about right here. That's where their lines cross, and that's about 30 degrees Celsius. Then number 3, if 100 grams of sodium nitrate is dissolved in 100 grams of water at 60 degrees Celsius, what is the solution form, saturated, unsaturated, or supersaturated? We're not even going to deal with supersaturated. It's either saturated or unsaturated. So 100 grams at 60 degrees, so find 100, find 60 degrees. It's about right here. This is our sodium nitrate line, so it's below it. So it's an unsaturated solution. And then if 32 grams of copper 2 sulfate is dissolved in 100 grams of water at 20, what type of solution is produced. So 32 grams at 20 of copper 2 sulfate. That's exactly on this X here. So if it's on the X, if it's on the line, it's saturated. So let's flip it over to the back. There's some questions here to answer over this graph. So number 1, it says, I'm going to write them up here this time. How many grams of sodium nitrate does it take to make a saturated solution in 100 cubic centimeters of water at 10 degrees Celsius? So find 10 degrees, find sodium nitrate, and it's right here at 80. So that's 80. Number 2, how many grams of KCl does it take to make a saturated solution at 60? So find 60, intersect with KCl, it's about 45. Number 3, how many grams of barium hydroxide does it take to make a saturated solution at 30? So find 30, intersect, this is the barium hydroxide line, so it's about 5. Number 4, if 40 grams of KCl is dissolved in 100 cubic centimeters of water at 90, is the solution saturated? How do you know? So let's find 40 grams at 90. So 40 grams at 90 would be right here. We're below the KCl line, so it's an unsaturated solution. How do you know? I'm going to say comma. It's below the line. If 40 grams of barium hydroxide is dissolved at 50, what type of solution is formed? Or is the solution saturated? I guess it says here, is the solution saturated? Instead of saying unsaturated, I'm going to say, I'm just going to say no. For that one. 40 grams at 50. So 40 grams at 50 is right here. We're talking about barium hydroxide. Here's the line for barium hydroxide. That is above the line. So it is saturated, yes. How do you know? Above the line. Number 6, if a saturated solution of KNO3 at 60 is cooled to 20. So let's find KNO3 at 60. It's right here. It's cooled to 20. It's right here. How much precipitate will crystallize at the bottom? Well, you've got 110, but you can only hold 30. So 110 minus 30 is 80. So 110 minus 30 is 80 grams. Number 7, if 70 grams of ammonium chloride is added to 100 cubic centimeters of water at 50 degrees Celsius, how much remains undissolved? So let's find 70 grams at 50. So I'm going to erase some of these lines on here. So 70 grams at 50 is right here. For ammonium chloride, you can hold 50 at that point. So 70 minus 50 is 20 grams remains undissolved. Number 8, at what temperature do KNO3 and NaNO3 have the same solubility? So let's find KNO3 and NaNO3. They intersect right here at about 70. So 70 degrees Celsius. Number 9, if 120 grams of sodium nitrate is added to 100 cubic centimeters of water, at what temperature will all the solute be dissolved? So let's find 120 grams and intersect it with the sodium nitrate line. It's right here at about 55. So 55 degrees, it's all going to be dissolved. And number 10, if 30 grams of urbidium sulfate, which is this line right here, is dissolved in 100 cubic centimeters of water at 10 degrees, what will happen if the temperature is increased to 60? So at 10 degrees, we have about 30 in there. And it says be specific, and we increase the temperature to 60. At 60, we can only have 10. So the solubility goes down. So we're going to say 30 minus 10 equals 20 grams will precipitate. And that just means it's going to come out of solution. So 20 grams of urbidium sulfate will come out of solution if we increase the temperature from 10 to 60 degrees, which is 50 degrees Celsius.